Hello, it's Crazy Logics. We got an Aurora Sound RPM Stage 2 of 5350. It's a 5-channel amplifier, 4 channels at 50 watts it says, and 1 channel at 150 watts. Save a little time. I've inspected the RCAs over here. You can see them on the edge. Checked all the screw terminals, made sure everything was out of them. Checked the fuses. Did a few other little things to try to save some time. We don't want these videos to go on forever. Everybody likes to get into the meat of it. So we're gonna go ahead and put our little resistor between B plus and ground. Make sure that is drained. We're going to get our multimeter. Let me get in here. Sorry this is at a little angle. To get this big of an amp in on my workbench and make it look alright, I had to, my camera's a little catty-corner. So the ground to the ground. And we're charging here. Should go all the way up to 1. It's going real slow. Uh-oh, it stopped. That's not good. So, we've got one that when we check the input power, and we're trying to check the input capacitors, and that also checks the power supply to make sure nothing's drawing power back out. Well, something would not let those input capacitors, smoothing capacitors, charge. So I've already got the bottom off here. You can see here we have, let's turn the overhead light off so it doesn't glare so bad, maybe. We'll turn it back on when we're working. We got the power supply comes in. These are the filter capacitors. It's a dual power supply. Looks like we got power supply fits here. That says D, so that's going to be a diode. That's going to be a diode. RTH. So we got a pair of diodes there. So we got 4 FETs on the power supply, and on each power supply, and we got a pair of rectifiers there that'll make the rail voltage. So I'm assuming one side here is probably making good power for the 4-channel, and one side is making power for the sub. So we're gonna get our multimeter out here. We're going to test. We test leg to leg, and then to the other 2 legs, and then across the other 3 is the way I always do it. That's not good unless it charges up. That's probably okay. That's all the power supply legs on this side. Now on the diodes, most likely they're center facing, a double diode, and one of them will be outward. So if you touch the outer legs, it should beep, because it's always going to beep, because they're the same thing. But you test the middle, and you should get a reading somewhere between like 400 and 650 or something like that from leg to leg. And then when you go backwards, it's charged the rail capacitors. If I can hold this on here. And there it's charging a rail, so that's cool. That looks good. So let's go over here. Got a beep. We got a beep, and it's staying a beep, and look at the readout on the multimeter. It's staying 0, 0, 0. So that right there is not good. That second one shows bad. That one's okay, it seems. That one's okay, it seems. Okay, so this first one and possibly this second one, so probably going to have a pair of 2 and a pair of 2, are bad over here on this power supply. So let's go ahead and get this sucker taken apart. Now use your cell phone or a camera or a piece of paper and pencil and draw you the layout of how these bars go on, just in case if you're not going to remember. Especially if you might have to order parts or not be able to finish the amp immediately. Now I don't have to because I got this video recording. I can always go back and watch it to see how something was laid out. So we get the amp out of the case. Now we got a ground wire here. I always like to kind of bend these around and get them up and not touching something. Get all these screws out. I've taken a few out already in the case to try to speed this up. Nobody wants to watch somebody take screws out all day. We'll save that stuff if we ever are doing live stream, then we won't mind because we can do chat during live stream during the boring parts. So, and I'm still learning video editing software, so cutting out or speeding up a whole bunch of boring stuff is not where I'm at yet with my video editing skills, but part of that's due to recording with my cell phone. So 2 screws held in this board, and it comes up and out, and this is the whole input setup except for very little. It's got the RCAs and everything on it, and you can see it here. It's a little dusty. I'll carefully set that out of the way. Now we got screws holding the board in. We got to get the board out because got to be able to get to the back side of those legs on that fet. I'm a hurrying. If you've seen my fat bald head, I'm sorry. Let's see, I've already taken those screws out. We got center screw here. That's a good design. Center screws in the board help keep the middle of the board from bouncing and wobbling. Looks like we're about free. We screwed anywhere there? No. We may have to take these out. Maybe holding the board down. That may be the other screws. Yep, looks like the standoffs. Hold that sucker in. Alright. Looks like what we got holding this up here. Little something. Aha! Right there. Can you see it? Little wire coming. My fat head might have got it in the way. That is the LED in the front panel. Unplug that. Pull out of this little wire. Now, this whole thing should come out. Alright. We're going to make sure all these little mica insulators are off so that they stay in the case cover for now. They go on all these metal backed FETs or transistors if they're class AB. And we want to make sure we got them all and they all stay in here. And that thermal paste is old and not very good. You can see a lot of it's got dried up. Set that carefully out of the way. So our problem was over on that side. So it should be these FETs right here. We know it was these first couple ones. Now one of them may be good, but they're probably in parallel, so Let me show you how you figure out if they're in parallel. Get a little closer here. There we go. We'll go on this good side. So all these FETs are going to have drive resistors. This is actually the driver board. It goes through these transistors, it looks like, probably, and drives these FETs. Now these are IRF Z44Vs there, and all the same there. Now they're all going to have, they should have anyway, the same batch code, 214H. 214H. Yeah, 214H. So you're going to, underneath the part number, and you guys can't see it very well. When we pull them off, I'll bring them up either to the camera or put them under the microscope. Actually, Mike. That's not going to work. Let's try going. To the microscope. You just barely see. So there's a part number, IRF Z44. This is an N. But you'll see down there at the bottom, like that's a B9PO, and or it's either a P54OD. You'll find matching date codes on there. And they should all match up. There's a reason for that. They are in parallel. So let me switch back to here. So here's another pair. These are slightly different style. But basically what these are is these two are in parallel with these two. And what that means is basically they're kind of like this, where they've been paralleled up. So that if this one, let's say, is good for 5 amps, and they're all good for 5 amps, if I parallel these two, now I'm good for 10 amps. And there's always going to be 2 banks, normally, because it's a push-pull on the power supply. And oh no, we don't want to do that. We want to put those back in their sleeve. So anyway, the way you can find out how many are in parallel is normally it's divide by half. So these are rectifiers down here, and we know that because it's labeled D8 and D9 on the board. You can't see it real close here, but I don't have a good zoom for that yet. And since you'll have a bank, but you can test. This right here is going to be the gate leg, this farthest one on this side. And you can go to the gate driver resistor and touch with your meter on continuity. And so this one, actually the junction is on this back side. Let's see if I can touch that. The junction actually goes from this leg over to here. So that means this side is the one that goes over to the transistors. So if you touch this side to the next one, see how those are together? That means both of those are being driven off the same spot. Well, I can touch these two over here and nothing. But one of these two, not so easy to get. They got some goo in here. Not that side. Our resistors are not reading well. Okay, that's that one. That must mean that this one is there. No. Oh, that's that one. Oh, so it's going to be these two. Yeah, there we go. The way those are wired, it's those two. A little hard to do on that side. This side actually would be a little easier. Get a little better view. Maybe I can control the camera just a little bit. Nope, that's the maximum zoom I've got. So you can see on this one, so here's our bad ones. Let's go to these good ones. That's going to be the gate leg. And that's going to be the gate leg. And if you check both of these, they're matched up. Do the same on this one. Yep, they're matched up. So we are going to take those two bad fets out. So the first thing I always do is I get my leaded solder, because most of this stuff you're going to be working on is going to have lead free. Lead free, let's just say for instances, lead free has got a melting point of 500 degrees and leaded solder has got 400. By adding some leaded solder to all these joints, you're lowering the melting point as those two different solders mix, which then makes it easier. Now there's something that I like to do when I go on here, and that's get my little magnifier or my cheater glasses, and you want to look, let's see here, you want to look at the fet legs really, really close, because there can be, when the factory puts them in and cuts them off, sometimes it'll develop burr right on the ends of these, and that burr won't go back through the hole very well. So if they have a burr, you need to get you a good pair of sharp nippers and clean that burr off. These I've looked already and they don't have a burr, so we're going to get our beefy soldering iron here. This one's a 50-watt Unger. We're going to get a little solder on it, and we're going to add some solder to all these spots. Now I notice that right there looks a little goofy, so I'm going to get my inspector out here. Get a hold of this thing without dropping it. That almost looks like it's broke, but well, that should be beeping like a son of a gun, just like that. Yeah, there we go. Just had a little, I don't know. We may end up having to put a little wire there. When this one blew, or this whatever, I'm assuming it's this one that's blown, it may have heated up that trace and caused it to get weak and break. So let's go ahead and add some solder to those three legs. And this will probably be part one of two parts. I don't want to make these videos too long. Everybody's interest falls out. So we can do this one of two ways. You can get a pair of tweezers, since these are metal backed. Clean up your soldering iron tip. Always keep it clean. Sponge, copper Brillo pad, but always get it clean. So if there is no burrs on there, if you got a good nice big hot soldering iron, you can touch all three legs and just get it to drop right out. If there's burrs on it, they won't drop right out. Once you've heated it up, sometimes it's easy, sometimes it's not. But always, like I said, just drops right out. You'll notice there's no vias that get pulled that way. So now we can come back in, clean up our soldering iron with our desoldering tool, and clean these up. soldering tool sticking. I will clean that up later. We'll go to the old squish bulb. Works just fine. There we go. We've got the holes all filled in. I'm going to give this section of the board I thought might have been damaged another look. Yes, it is damaged. Let's see if we can get that under the microscope. But now that we got these two FETs out, I noticed I placed them in the order they came out because we kind of want to know. That's a good habit to be in. You can touch the back of this FET. The back of this FET's going to be the same as the middle leg always, if it's a metal back. So we touch this leg and touch that leg, and that is a dead short. We touch this one, and that one don't check as a dead short. That is good news. So we're going to clean this up just enough so we can not get white goo all over us. And we're going to have to repair that trace on the board. That's a middle power leg, so we're going to want to do that with something a little bit beefy. And what I will use is actually my desoldering braid. We'll save a good clean section of it. We'll run it way back in here, and we'll split it around here and kind of wrap it around that leg. We'll get these two posts soldered in and leave that middle one until we can get that braid all nice in there. And that laid down into that, bedded into that solder, will provide way more continuity than that poor old little trace piece ever did. So that'll be a nice permanent repair. So when this one blew, it burnt that trace out there too. So the one thing we did not do, actually I did, was check. So we're going to have these are special spot. Let's go ahead and do it. Was check all the outputs here. I have actually already done it. I'm picking these amps. Here's the meter. Specifically to show problems, trying to do this in order, and then we'll get wild and crazy and get out of order with my other videos I did with my phone once I get those edited. But I picked a few either based on what I see is wrong with the amp, and if I have the parts already here so that I can actually do a completed. Nobody wants to watch a video and then have to wait 2 weeks while parts come in. So all the output FETs seem fine. So I'd say they ran this a little hard. That one FET was the weak spot, or maybe due to some vibration, we got a crack there. But since this board actually has center holes, I'd say they ran this all the way up. If this is the sub side, I don't know, we haven't powered it up. But if this is the subwoofer side and they were hitting it hard and maybe running the other part of it less hard and blew that FET caused that to burn open. So I don't know if I've showed my little tester. You can get all kinds of different versions of this. Let's move this up and out of the way. This one did not come with a case. You can get them in a nice big case. They look fancy. But they're transistor testers. They check diodes, capacitors, all kinds of stuff. They do not replace quality instruments. You know, this is kind of an all-in-one run on a microcontroller. But it really does help to let you know what stuff like, is that the shorted one? Did I get those out of order? Well, somebody's going to be watching that video and going to have to rewind and see if I set those down out of order. That one's shorted, that one is not. So I did. That one goes there. That's the dead one. We don't want to self-test. All right. This, if you short all three of the legs together, it puts itself into self-test and calibration. We don't want to do that. That's why you normally don't ever put a known shorted like that one. See where we know it's shorted on the two outsides on the tester because it'll go into calibration. So we test this and it comes up. It's a an N style enhanced MOSFET. It tells us NE MOS. It'll tell you which legs based off the number of these wires is the gain, source, and drain. It'll give you a VT, which is the voltage turn on kind of, and then the capacitance of the gate in nanofarads, so 2.99. So this is handy if you had a big amplifier with a whole bunch of FETs and only a couple of them, like this one has died. Sometimes you can go through and check all those FETs and look for big discrepancies in those numbers, you know, all the ones that seem good with your multimeter, and that'll tell you if you got a big discrepancy, that FET was really damaged and it just hadn't completely blown, and you can chuck it. But what you keep FETs like this for, that are now, this was a pair in this board, you keep this FET for testing purposes. So I've got me a whole bin of used ones here that I keep, and whenever we've made our repairs, if I had a whole blown power supply, and let me get this back over here. If I had a whole big old blown power supply, so let's say all four of those and all four of those had blown, I could go back through and maybe find a couple that weren't blown. And actually, since this is a pair, for testing purposes, you only have to have one FET in for every parallel bank. So I'd actually only have to have a FET there and a FET in one of these two places, a FET there and a FET there, and then we could put test bench power and test it. Now, when you have that much damage, if you've blown so many of them, you're normally going to drop it, and we're going to look at the driver circuit that's on the other side right here where the transistors are and stuff, because there will be damage to those transistors. One way you can tell if you think there's going to be damage to these transistors is inspecting these little drive resistors. If they don't look bad, there may not be. We could power this board up right now and we could check all the drives, and that's probably what we're going to do in the next video, because we're coming up on 30 minutes. So we've got one bad FET, and so somewhere I've got a silver marker, but mark it with some other color so we know that one's bad. And the somewhat good working one that we could use for a test, throw in the used bin. And we'll get out our good box of IRF Z44Vs. Now, I actually have, looks like a pair of these. They look like they've been soldered for a test. And I believe these were the ones I got first out of this kit. Or they may be the last of the last batch that I got. These I keep them all together if they're all the same batch number. And then in the good, I think I'd actually had one pack of these that I ended up with 2 FETs left. So I used them in a test because I didn't have me very many of the IRF Z44s. But that's why you keep your used ones. If you do, let's say like I didn't have any of these, and you're going to replace these and it had been, all of them had been blown up, you're probably going to want to order, instead of just 8 to replace them all, probably going to want to order 4 extras and make it 12, so you can put 1 into each spot and test. And if there's something still bad and you pop a FET, you'll still have enough FETs to do the repair. And that's what this was. These were just slightly tacked in. So I've actually got 2 nice matched FETs that we're going to use to put in there. So we keep our old FET because it's going to show us where to bend the legs. Oh, sorry, I'm not under the camera. We keep the old dead FET because it's going to show us where to bend the legs for the new install. But I want to go ahead and I'm going to set up in between shots here to I'll add this board back in. Maybe might be able to just set it in there. I'm not sure if it needs to be in there or not. I don't think it does. I think all the power supply stuff's there, so I think we can just go ahead and leave that out. But we're going to hook up power, we'll run that and we'll check the signals on the oscilloscope up there in the corner. I can go all the way up live there, and we'll look at that, and then we'll talk about the drive chip, and we'll talk about ways you can measure it just with your multimeter to get a good idea, because actually the drive voltage that's going to all these legs should be roughly half of whatever your input voltage is. So if you're 12.5 volts, you should be 6.25 volt or so on these normally. That won't show you a pretty wave. You got to have an oscilloscope to check the you know, the pretty wave, but that can give you a pretty good idea. You know, if all these on this side that's good are all measuring 6.25, and you go over here and you measure these two and they're 6.25, and we measure these two gates and they're 6.25, then we know we're probably all right. We do have a little solder blob right there still. I want to take care of that. We won't be able to put new fence in. Excellent. All right, like I said, I'm going to end part 1 here. Part 2, we will test the drive. We will install the new FETs using the old FET to set the bend for us and make sure it's lined up here so the new FETs go in the new spot. And if everything checks out, then we will do a power up. I'll show you some other tests. We'll stick it back in and we'll play some music through it. Hopefully that's all that's wrong with it, and we'll know then. Also in part 2, since that'll be hopefully pretty quick, I'll show you a sneak peek of some of the upcoming amps. Got a J&L Audio and 2 Rockfords I want to make videos of, because everybody wants to know about those amps. Those are very popular amps, and so let's do a couple of those coming up. All right, we've ran on long enough. I'm going to stop this one and prep for the next, and you'll see it the very next day, hopefully, because I'll hopefully record it tonight, but this one I'll have to process. If this helps you out, helps you troubleshoot all these videos together, kind of learning, stacking up, subscribe, you know, all that crap the YouTubers are freaking out about to do. That's great. Comment down in the comment section. Oh, look at these caps, are real good too. I want to make sure they're not swole up. I feel a little pokey. I don't know. We may unsolder those and test those. I don't know if I got that size or not. Don't look like they're dead, but we'll do that. So, like I said, thanks for watching my videos, and I hope you learned something. And leave a comment, and you know, ask questions or something, and I'll try to tell you what's coming up so that you know, and we'll do some other fun videos that will help you when you go to buy a used amp, other stuff like that. So, Crazy Logic's signing out for this one. See you in part 2.